Welcome to the deep dive. Look, if you're trying to keep up with cloud tech, especially security and data management, it's a lot. Feels like trying to drink from a fire hose, right?
Yeah.
How do you stay informed, actually get the key insights, and, not just get overwhelmed? Well, today we're going to try and cut through some of that noise. We're doing a targeted deep dive, really focusing on critical concepts in cloud security, data management, looking at real world stuff across the big players: AWS, Azure, Google Cloud. And here's how we're doing it, which is a bit different. Our source material, it's actually a set of practice questions from the 31240 exam practice, Cloud Security and Data Management. We're basically using them as a lens, to pull out the really critical knowledge.
Exactly. And our mission here, for you listening, it isn't just about getting the right answer to a question. Not at all. It's about pulling out those key nuggets of knowledge from these scenarios, understanding the why. Why does this concept matter? We want to make some pretty complex stuff digestible and really practical for you, whether you're prepping for something, catching up, or just curious about how this cloud stuff actually works.
Totally. And yeah, just for context, that 31240 exam, it's 125 multiple choice questions. You get 4 hours, need 70% to pass. It's done through the EC Council portal. But let's be super clear today. We're focused on the knowledge, the practical insights, not the exam itself. So let's just jump in. Okay, first up, keeping cloud instances secure. It's not like you set it and forget it, is it? New vulnerabilities pop up all the time. Keeping things patched, compliant. It feels relentless sometimes. What are the big challenges here? And how do the cloud providers help automate this?
Oh, yeah, that's a huge one. I mean, just the sheer volume of vulnerabilities and how fast they appear. Manual patching, it's almost impossible we've got any kind of scale. And that's exactly where a service like AWS Systems Manager, Patch Manager really comes into its own. The question we had was, in AWS, which service helps automatically apply security patches and update compliance status across EC2 instances to reduce vulnerabilities? I don't know. And, well, that's it, Patch Manager. It automates applying patches, not just security ones, other updates too across your EC2 instances. It really cuts down on that, patching fatigue, that feeling that often leads to systems being left vulnerable. The key thing here, the insight for you, is that automated compliance is not just a security checkbox. It frees up valuable engineer time, and you're proactively shrinking your attack surface.
Right. That sounds incredibly useful. Automating something so critical and honestly, often kind of neglected. Okay, so let's say your systems are patched, they're secure at that basic level. What's the next layer? It's got to be who gets to touch these systems, right? And under what conditions? This takes us beyond just static security into dynamic access control. Our next question hits this directly. In Microsoft Azure, what feature allows you to restrict access to management operations based on conditions such as IP address or device compliance?
Yeah, and this is where conditional access policies in Azure are, well, pretty brilliant. They go way beyond just a password and basic permissions. The real power, the insight for you, is that they act like a smart security card. They don't just check your ID. They look at where you're logging in from, what device you're using, even assess your sign-in risk, like in real time. So security isn't just a one-time check. It's continuous, it's intelligent, makes it way harder for stolen credentials to cause damage. Absolutely key for locking down management tasks and sensitive stuff.
Okay, so patching dynamic access, that builds a strong perimeter. But what if a threat still slips through? Or maybe it starts inside your network. That's when you need something more proactive, right? Something that can spot malicious activity happening right now, even inside running VMs, runtime threat detection. So the question here, in Google Cloud, which service allows organizations to detect threats like malware or cryptocurrency mining in VM instances by analyzing runtime behavior?
Right. For Google Cloud, that service is Security Command Center Premium. Think of it as a sort of central hub for security and risk management in GCP. What's really crucial about it, and the key takeaway for you, is its ability to watch the runtime behavior of your cloud resources. Your VMs, for instance. It's not just looking for known bad files like old antivirus. It's analyzing what the VM is doing. Is it suddenly trying to mine crypto? Is malware executing stuff that might slip past traditional defenses? It's a really powerful layer for finding threats that are already inside.
Huh, interesting. So connecting that idea, how does a cloud provider automatically spot just generally suspicious activity? Using smart analytics, maybe not tied to one specific VM's behavior, like which AWS service does real-time detection and can automate responses based on weird user activity using behavior analytics.
Okay, yeah. You're describing Amazon Guard Duty there. It's a threat detection service that's always running, always monitoring your AWS accounts and workloads. What makes it so effective, and this is important for you to grasp, is its use of machine learning and behavior-based analytics. It doesn't just rely on lists of known threats. It learns what's normal for your environment and then flags anomalies, things that are weird, out of the ordinary. Could be unusual API calls, maybe signs of compromised credentials, weird network traffic. It's constantly watching, learning, and it can even kick off automated responses. It's a great example of proactive intelligence security.
Okay, so pulling these together, threat detection, access control. What's the fundamental idea, the core philosophy for stopping breaches just by limiting what people can do from the start? This brings us to a really basic but crucial security principle. The question puts it like this. A cloud security engineer wants to minimize privilege escalation by ensuring users can perform only the actions needed for their job. Which security principle should be applied?
That is the principle of least privilege, and it's absolutely fundamental. Doesn't matter if you're on AWS, Azure, Google Cloud, whatever, it's foundational. It just means that any user, any application, any system, it should only get the absolute minimum permissions needed to do its specific job, nothing more. By doing that, you drastically shrink the potential damage if something goes wrong. You limit the attack surface, reduce the risk of privileges getting escalated, cut down on accidents. It's core to solid security. Because even if, say, credentials get compromised, the damage is contained because those credentials didn't have permission to do much anyway.
That sounds so fundamental, almost obvious. But why do so many places seem to struggle with actually doing least privilege well? What's a common mistake?
Yeah, that's a great question. I think the biggest hurdle is often just operational convenience, frankly. It's almost always easier, faster in the short term to grant broad permissions than it is to sit down and figure out the precise minimum set needed. But then you get what's called privilege creep. Over time, users just collect more and more permissions they don't actually need. The struggle is that doing it right requires ongoing effort. You need to audit, adjust, have the right tools and discipline. But honestly, the reduction in risk, it's massive. It's worth it.
Yeah, that makes total sense. Okay, changing tack slightly. Before we even get to securing data, we need to know what kind of data we've got, right? It feels basic, but it underpins everything in data management. What exactly is structured data? The question asks. Which type of data is stored in a defined format, such as rows and columns, making it suitable for relational databases?
Simple enough that structured data, it's data that fits neatly into predefined fields. Think tables, rows, columns, like a spreadsheet, basically, or customer records in a database. Your typical CRM data, accounting transactions, that kind of stuff. It's easy to search, easy to organize. And yeah, perfect for traditional relational databases like MySQL or PostgreSQL. Understanding this kind of data classification, structured, unstructured, semi-structured, it's really the first step. You got to know what you have before you can protect it or manage it properly.
Right. Okay. So once we understand the data, how do we then enforce the big picture rules? The organizational governance across the whole cloud environment, make sure everyone's following the same playbook, staying compliant. Which Google Cloud feature allows administrators to define constraints that prevent the use of specific services or resources within a project or organization?
In Google Cloud, the tool for that is the Organization Policy Service. It's really powerful for enforcing rules from the top down. Administrators can use it to set constraints on how cloud resources get used across the entire company, or maybe just within specific teams or projects. For example, you could say, nope, developers can't deploy these specific risky services, or all data storage must happen in this region to meet compliance rules, or maybe only these approved types of virtual machines can be created. It's crucial for keeping things consistent, controlling costs, and making sure your overall cloud strategy is actually being followed on the ground, high-level governance.
And speaking of managing all these resources, just practically, how do you keep track of everything, especially when you have tons of VMs, storage, databases? How do you handle things like billing, figuring out who spent what, or just knowing who owns which resource? The question here is about Azure. What is the primary purpose of using tags on Azure resources?
Tags. Yeah, the primary purpose of Azure Resource Tags and tags exist in AWS and GCP too. Different names maybe, but same idea is organization and classification. They're basically just metadata labels, little key value pairs you attach to your resources, like department, finance, or environment, production. And they become incredibly useful. For cost management, for one, you can slice and dice your bill based on tags to see exactly which team or project is spending what, but also for governance, like finding all resources tagged PCI compliance, or for automation running scripts only on resources with a certain tag. It's simple, but really effective for managing complexity, brings operational clarity.
Okay, cool. Let's shift gears again, moving from managing the infrastructure to how the applications on that infrastructure talk to each other.
No.
Especially in modern apps, you've got lots of small parts, microservices maybe. How do they communicate securely but without being rigidly tied together? Decoupled. Which AWS service allows secure, decoupled communication between microservices or applications using a hosted message queue?
That would be Amazon SQS Simple Queue Service. It's a fully managed message queue. And that keyword, decoupled communication, is really the heart of it for you to understand. It means different parts of your application, maybe different microservices, can send and receive messages without needing a direct, real-time connection. They just drop a message in the queue, and another part picks it up when it's ready. This is huge for making your applications more resilient and scalable. If one part slows down or fails temporarily, the messages just wait safely in the queue. It prevents failures from cascading through the whole system, makes everything more robust, and it does it securely.
Right. That makes sense for keeping applications running smoothly. Okay, last area, a really critical one, disaster recovery, especially getting data replicated across different regions, maybe with some serious encryption involved, protecting the crown jewels, basically. Our final question. A company wants to create an encrypted, read-only replica of a Google Cloud SQL database in another region for disaster recovery. Which solution best fits this scenario?
Okay, for that specific need, the best fit is using a GCP cross-region read replica with CMEK. Let's break that down. Google Cloud SQL lets you create read-only copies, replicas, of your database in completely different geographic regions. That's your disaster recovery piece right there. If one region goes down, you have a copy elsewhere. It also helps spread out read traffic, by the way. Now, the CMEK part stands for Customer Managed Encryption Keys. This is key. It means you control the encryption keys used to protect that replicated data, not Google. This gives you an extra layer of security and control, often needed for compliance or data sovereignty rules. You hold the keys to your data. So yeah, it's a pretty sophisticated solution for when you need robust DR and tight control over data encryption across regions.
So maybe here's a final thought for you to chew on. We've looked at all these different services, different principles across AWS, Azure, Google Cloud. What does that tell us about the universal challenges, the foundational problems everyone faces when trying to secure and manage data in any cloud, regardless of which logo is on the bill?
That's a great point. It really highlights that while the tools, the specific service names, might differ, and yeah, the implementations have their quirks, the fundamental problems they're all trying to solve, they're remarkably similar. Protecting data, controlling who gets access, spotting threats early, ensuring the business can keep running if disaster strikes, managing all this stuff without breaking the bank. These are universal enterprise-level challenges. And each cloud provider, they're basically offering their own toolkit, their own approach to tackle those same critical needs in this multi-cloud world we live in.